welcome everyone to this tutorial for beginners on Logisim. So today I'm going to show you what it means to have this Logisim environment, are the different things and components from where you can get them, and how does it work. So Logisim Evolution is actually a software, educational software, so you can simulate the digital circuits that you design. So in theory, you know how to get the Boolean expression, you can draw the circuit, but to see if this circuit acts as you expect in the theory and in the truth table and using the math that you use in your design, you want to see it if it actually acts the same way, do you get the same results? You can do this by simulating it on Logisim. This software is free, open source, so it can be easily downloaded. So the link is actually on GitHub. And the nice thing about it, you don't need to install it. It is an executable file. So once you download it, you just click on it and it will open. However, you do need a Java application. So make sure you have the latest updates for Java. I think this is the best option. Or here it says it requires Java 16 or newer. I believe you have also the Logisim file on Blackboard, so you should download it, and it looks like this. So just double click. Please put it in a folder where you can access easily. And the version name is usually on top, so make sure you also know what version you are using. So it looks like this. So this is actually like just the board where you connect your circuits. You do have some, so for the version 2.15, this is how it looks like. The other version, like 3.8, looks a bit different. And we have the main tools that we need on top here. So we have like inputs. So if I need to put an input to be 0 or 1, I can change the input value with this hand, which is what we call a poker. So when you click on this, you're no longer designing, you are actually testing. So here, if I want to be 1, it's like a switch that you press on and off. So this is the input I, and this is the outputs. For example, let's design a basic AND gate. So you can actually find the basic logic gates up here. So you have the NOT, you have the AND, you have the OR. Let's say I want to see the AND gate, so I'll connect my output here. You can call it F. So double click to have the name of the output. And I'll just copy paste this input, and one I'll call it A, the other I'll call it B. And I will just connect them to this AND gate. Make sure you connect to these dots, because if you do not connect to the dots, it will not be connected. So and so we know the AND gate is always 0, except if both inputs are 1. So you see now that it's 1, 1, our output is 1. So this is the nice thing about Logisim, you can verify your designs. Of course, the AND gate was very basic, but it's very useful for bigger designs like for your project. Now, apart from these tools that we have here, these are the folders that contain all the components. So for example, wiring is very useful folder. We have the splitter. We will use this when we want to join or split a cable, so or a bus basically, which basically a wire that carries many bits. So it could be 8 bits, 6 bits. We have also the clock signal. And notice anything that you click on, you have the properties here. So each component has its own properties. For example, let me click on the AND gates. The AND gates, you can choose the number of inputs, so you don't always, sometimes you need multiple inputs in an AND gate, 3, 4 input AND gate, so you can change that. You can also, for example, let's say my circuit was, I had a NOT here. Instead of making a NOT gate, I can just say negate. So the top, for example, B, it's not B in the equation. I'll make negate yes. So this will make a bubble, which is an inverter. and it will act like a NOT gate. Another useful thing, especially when you have a big circuit, is not to use wires. So instead of wires, we're going to use a wireless way of connecting, which we call tunnels in Logisim. So I'll remove the wires. It doesn't really make much sense using them on a small circuit, but they're very useful when it's big. So this is the tunnel, it's in wiring. And the idea is that you connect it to the input and call it A. And then we connect it here and call it B. And then we connect here another tunnel and call it F. And this now carries what is an input A. So for example, I want to make my circuit. I'll just create a tunnel and call it A. So these two are actually connected. So this is like a wireless connection. And the same for B and F, we can do the same. We have also the folder gates. Here you'll find all the gates, XOR, XNOR. We have plexers folder, so this is for the multiplexers. You also have a decoder here. We have arithmetic folder. So actually you have in Logisim ready adder, comparator. So I think you know how to design this, but you also have a building block that is already ready for this full adder combinational circuit. So here you put your inputs that you want to add. For example, you want to add A and B. And notice that here it's expecting 8 bits. So this is expecting an 8-bit number. If you want 1 bit, you have to change. And here it's Cin, which is the carry in, here the carry out, and this is the output of the summation. So you see you have many, this is the comparator. Again, you are comparing between two numbers, and if the A is greater than the B, this will be 1, these are 0, and so on. So you should use the theory that you learn to explore how these different components work. We also have the memory folder. We have all the flip-flops here. We have also a register. So this is a register with many D flip-flops. Again, you have to choose what type of trigger. So this depends on your design. Is it rising edge? Is it falling edge? The number of bits, very important. You also have a counter, if you need a counter. You have a shift register, and you also have a ROM. So this is also important for the projects. And you can explore all other folders. So this is input output. If you need a button, if you need LED light. LED light is useful to check the output. So let me bring back the circuit, delete all the other components. So I'm connecting an output to this AND gate, but I'm also putting an LED light. And the LED light helps you see when the output is 1 and when is it 0, visually at least. So here is the same circuit. I just changed it to tunnels. In case I need A and B again, I'll just copy and use the A somewhere else. So I don't need to connect a long wire and then all the wires come across each other. So this is my circuit. So I also let me remove this NOT so that I have just the normal AND gates. So you see when the input is 1, 1, the output is 1, and the LED light is on. So it helps you detect the 1 easier when you are testing. We also have the hex digit display. So I will use it solving one example. Now the hex digit expects 4 bits. This is the hex number. So you will need a splitter here, and we'll see this more in details later. So let's try to solve a problem, maybe more advanced circuits. We have this combinational circuits with the equation F equal not A, B, not C, plus not A, B, C, plus A, B, not C. And we want to design this circuit using Logisim and check what is the output for all the combinations so we can fill the truth table. So just copy this as a text. So here the A makes a text. Okay, it's not pasting. So F is equal. I think it's not easy to paste this. Okay. Or let me just put this into the side. So let's make this circuit. So we have, notice this is AND, but it's expecting 3 inputs. Now we have inputs A, B, C. I'll just make them up here. So A, B, and C. So usually we make the inputs as vertical lines, like this. And if you know that you're going to use the knots of each input as well, then you should have like another wire just for the knots. Or you can negate the gate itself, so that's up to you. I think on the slide here it's showing. So I'm gonna do it in maybe an easier way. So you already saw the slide example. Let's do it in a different way here. And you can choose whatever you feel comfortable with when you are designing. Okay. So we have 3 AND gates. I'll also try to use tunnels. So let's use tunnels here. Instead of connecting them directly to the gates. And we have 3 inputs AND, so so we have to go to the properties and change the number of inputs to 3. And I have 3 input AND gates. I think it's easier here for the circuit to use direct wires. So let's just use direct wires. Now we have not A and not C, so I'll negate the first one and the last one, the third one. Here A. And it's better to connect from the gate or the component to the inputs. And we have here C. For the second one, second AND, only the top one is inverted. So and for the last one, it's the last one that's inverted. So to connect the wires, you have to keep pressing until you reach the point where you want to connect. So now we did the ANDs, now we have to connect them with the ORs. So the output of each AND is ORed. And again, we have needs a 3 input OR for this. That goes to my output F. So let's see if we get the same truth table as what we designed. So if it's all 0, it should be 0, good. So I'm gonna try each one here. So 0, 0, 1, also 0. 0, 1, 0 should be 1. 0, 1, 1 also is 1. And then 1, 0, 0, 0, 1, 0, 1, also 0. And 1, 1, 0 should be 1, correct. And finally, all ones, it should be 0. So this is how we verify that our design. For the second problem, here we have already a truth table, and we have the circuit also again with 3 inputs, but this time we have 2 outputs, N1 and N2. And it's asking us that we have to design a circuit that displays the results, which counts the number of ones at the input. So here we have only one one, only one one. Here we have 2 ones. Here we have 1, 2 ones, and so on. So this is how the output is written with respect to the input. And it should display this result. So here we can see that we see number 0, 0, which is 0. Here we have 1 because it's only 1, 1. Again, here we have 1. Here we have number 2, indicating that we have 2 ones in this number, in the input. So this is also a good output. This is also telling us how many ones they are there, but we want to display it using decimal numbers. And to do this, we can use the hexadigit. So we have to put these into here. So if we have 0, it should be 0. If we have 1, 1, it should be 1. If 2 ones, should be 2. So we have only 0, 1, 2 as the, and also actually we could have 3 ones. So it could be 0, 1, 2, or 3. So let's see how to do this. Now, from the output, each output, we have to calculate the min-term notation, a Boolean expression in min-term notation, and we will figure out that N1, based on these min-terms, is basically A XOR B XOR C. So here we have this XOR gate with 3 inputs. The N2 is actually maybe with more logic gates, where with maybe 2, 3 ANDs. So we have B and C, ORed with A and B, ORed with A and C. So we have 3 AND gates and 1 OR gate with 3 inputs. So let's design the circuits. So I'll keep the same inputs. I think I'll just undo everything. So let's get our XOR. So you'll not find it here. We'll go here. You can use 2 XOR gates together, or just use a 3 input XOR and put them all at once. So this is for one output, which is our N1. And notice that N1 is the least significant bit. So it's the one on the right. N2 is the most significant bit for our output. So let's bring the AND gates. So we AND B and C, A and B, and finally A and C. We need also an OR gate, 3 inputs. So go to properties, change to 3 inputs. And this basically will be the output for my N2. By the way, when the wire is light green, it means it's reading input 1, because these wires really carry the signal, right? So if you're carrying a signal 0, which is basically there's no like current or voltage, or you're carrying a signal 1, which will be carrying a amount of voltage and current. So when it's 1, usually it will be light green, so it's telling you all these wires have 1 in them, also these. And when it's 0, it will be dark green. So in this case, only this wire here is carrying 0 in our circuit. If it's red or blue or orange, it means there's an issue and you have to fix it. So let's test our circuits. Oh, so actually my circuit is not working correctly. It means there's an issue. And I already see it, but I connected B twice. So this should have been C. Using the XOR 3 inputs, you have to be careful because this could behave in 2 ways. So if you want it to behave like a cascaded XOR gate, so either put 2 XOR gate or go to properties, and then here you have to choose the behavior and choose when an odd number are on. So this will give you the same XOR gate as you have it cascaded. So now when we have 3 ones, it's saying number 3. Let's display this on a hexadigit. So I'm gonna go to outputs. Let me close all these folders. Yes, I need the inputs, outputs, and hexadigit display. Now, this is expecting 4 bits as a hex digit. So I'll need a splitter because here I have 2 bits outputs and they are separated clearly, N1 and N2. I have to use the splitter and you have to connect basically the thick wire, which is usually in black. So in Logisim, if a wire is black, like you cannot see the color like this one, it means it's carrying multiple bits, which is what we call a bus. Now it's saying incompatible with, so this is when it's orange, it's telling you I'm expecting 4 bits here and you're giving me only 2. So we need to give it 4 bits. There are 2 ways to solve this. Either you use the extender, bit extender, so in wiring, it's the same folder where the splitter is, this one. Show you where I can find it. So here, wiring, we have bit extender, and we will choose that the input is going to be 2, and the output should become 4. So all it will do is just put zeros, right, in the most significant bits, because you will add zeros and they will not affect the number. So the number, if it's 1, it will still be 1. So let's remove this wire here and put our extender between these 2. So this is 2 bits. And let me connect this here, the 4 bits. And this should be bit 0, so bit 0 is N1, the least significant bit, and this should be bit 1, which is N2 here. And now we can see that when we have 3 ones in the input, so this is actually could work like a car sensor. So if there is a car, it will be 1. So like when you go to the parking lots. So let's say, so here we can say, for example, 0, 1, 1 should be 2. Let me make this full screen. Only have 1, should be 1, and so on. So this is a basic circuit in Logisim, and you can try it. So whenever you have issues or technical issues with Logisim, you can send an email or come to office hours. I'll also upload another tutorial which uses more advanced components in Logisim, like the ROM, multiplexer, and so on. Thank you for watching.